The inlet and throat diameters of horizontal venturimeter are 30 centimeter and 10 centimeter respectively. So now I will write the given data. Step number 1, given data. Let me take the black color. Yes, the D1 is equal to 30 centimeter. Convert into meter, 0.30 meter. And D2, because he has used the word inlet and throat, now it is a venturimeter. It is not a general device used for measuring the discharge. Particularly, he has used inlet and throat. So I will take D1 and D2. That is 10 centimeter. It is 0.10 meter. And this condition is also important. Horizontal venturimeter is also important. That I will write G1 is equal to J2. Because for horizontal, the potential energy or the height of inlet, I will draw one simple sketch of the venturimeter. This is venturimeter. This portion is inlet, section 1. This portion is outlet, that is throat. So between these two, they maybe used manometers or pressure gauges. Okay, here is the direction of the fluid. And dear students, keep in mind, the length of this converging end should be less compared to the length of diverging end. That is how you need to draw the sketch of the venturimeter. I have written D1 and D2. Next, the liquid flowing through the meter is water. This is also one important data. Fluid, that is working fluid, it is equal to water. So we need density of water. I will write here 1000 kg per meter cube. Next line. The pressure intensity at inlet is 13.734. Pressure intensity. You might have become confused with intensity word. Pressure, intensity or pressure both are same. And still if you are confused, look at into the unit of this. If the unit is in terms of Pascal, in the terms of Pascal, then you decide it is a pressure. Okay. So P1 I will write as 13.734 Newton per centimeter square. So convert Newton per centimeter square into Newton per meter square. 13.734 into 10 to the power of 4 Newton per meter square. So don't get confused with the word intensity and don't take it as pressure head, because unit is not meter. Okay, if this unit is meter, you could have taken it as pressure head. Next line, while the vacuum pressure head at the throat is 37 centimeter of mercury. So now unit is centimeter, meter, mm. All these are unit of length. So here it is in terms of head. Vacuum pressure at the throat. He has particularly given the word throat. So throat pressure is represented by the letter P2. But unit is 37 centimeter of mercury. There are 2 points where you have to be careful. One is with word vacuum. Whenever he gives the word vacuum, it is negative pressure. You take negative. And write down the values 37 centimeter of mercury. If vacuum word is not there, only pressure at the throat, then don't take negative. So now this centimeter convert into meter. So 10 to the power of minus 2. Instead of writing minus 2, I will write 0.37 meter of mercury. Still it is in terms of meter of mercury, but the fluid which is flowing through the venturimeter is water. So we have to convert in terms of water by multiplying specific gravity of mercury. Specific gravity of mercury, that is Sg. So I will write 0.27 with negative sign. I will multiply with 13.6. Then I will get P2 by rho G, because it is pressure head. Centimeter is a unit. So for that reason, it is pressure head. I will get minus 5.032. Now the unit will become meter of water. This is P2 value. Okay. Next, what is asked? Find the rate of flow. Rate of flow is also called as volume flow rate, or it is, you can use the word discharge. Both are same. So find first point, discharge is equals to how much? Next point is important. This is different compared to the previous numericals. Assume that 4% of the differential head, 4% of differential head is lost between inlet and throat. So there is a differential head between inlet and throat always. The differential head is represented by a symbol that is H. H is difference in head. So there is an extra or additional loss that is 4%. 4% of the differential head is lost. So total head loss, I will write head loss HF is equal to 4% of head loss. This is the one extra data he has given. So 4% means you remove the percentage just by dividing 100. What is the value of H? We don't know still. We need to calculate this H value. That we will do later. Whatever the data he has given, I am writing it. What is the data? Assume that 4% of differential head is lost between inlet and throat. So head loss due to many reasons, that is HF is equal to 4% of H. What is H? H is difference in head or pressure head difference. Both are same. So 4 by 200, but we don't know the value of H. That will calculate. What is the formula for calculating H? H is equal to P1 by rho g minus P2 by rho g. This is a one formula for calculating H value. Another formula is X into specific gravity of heavy liquid divided by specific gravity of the liquid flowing in the pipe minus 1. These are the two formulas. So here pressure P1 is given, P2 by rho g is also given. So we can use this formula, the first formula, because X is not given here. What is X? X is difference in nanometer level. That is not given here, where we cannot see any difference in nanometer level word in the statement of the numerical. So for that reason, I will go for the first formula. It is written on the screen. The next line, what he has asked, find also the value of CD, that is coefficient of discharge we need to find out. So in the previous numericals, how many numericals we have solved, he gave the value of CD as 0.98, 0.97, 0.99. But here particularly is asking the formula of value of CD. The value of CD is asking, so formula for calculating the discharge of coefficient CD is equal to, you remember this formula, H minus HF divided by H. This is the formula. It is not there in your curriculum, but sometimes in the industry they use for calculating coefficient of discharge formula. So coefficient of discharge is square root of H. H is difference in head minus the extra losses what he has considered in the venturimeter between inlet and throat divided by the H value. So that is a formula for calculating CD. Now whatever, and also he has asked discharge. Yeah, these are the two unknowns. So what we do, first we will calculate the CD. So this equation number I will take 1. And one more equation I will write, that is for formula for discharge. Q is equal to CD into Q theoretical. So why you are writing actual means we are calculating coefficient of discharge. Whenever he has given losses, you have to apply actual formula, actual discharge formula. If losses are not given, you go for theoretical. So Q actual is equal to CD, you write as it is. What is the formula for theoretical? A1, A2, square root of 2GH again divided by square root of A1 square minus A2 square. Now this you take equation number 2. So in the equation number 1, we need to find the value of CD. CD is depends on H value, H and HF. Both value we need to find out. So for that reason, we go for calculating H. So H is equal to, what is H? H is difference in pressure head. That value H is equal to P1 by rho z minus P2 by rho z, because it is a horizontal venturimeter. If it is vertical venturimeter, the formula may be changed. This is the formula for calculating difference in head for vertical venturimeter. We have to consider Z1 and Z2. So this is the actual formula for calculating H value. But here Z1 and Z2 both are same because horizontal venturimeter. So the formula will become like this. So substitute the value of P1. How much is given? P1. P1 will go to P1 value. Yeah, 13.734 into 10 to the power of 4 is the value of P1 that I will substitute here. 13.734 into 10 to the power of 4 divided by density of the working fluid, which is the fluid flowing in the venturimeter, that is water. That is 9.81 is the value of G. This is P1 by rho G minus P2 by rho Z directly has given. He has given in terms of pressure head. So that I will take directly. It is minus value. So don't get confused. Here is also minus in the formula by default, and the value of P2 by rho Z is also minus. So when you are substituting in the value in the equation, so you have to take minus. So 5.5 the value is 0.32. 0.32. So now simplify this equation. I will get the H, that is difference in pressure head value, is 19.03 meter. 19.03 meter is the value from equation number 2. In the equation number 2, the actual discharge is equal to something he has given equation. Now I will write from equation number 2. I will take a new page here. From equation 2, what is equation 2? That is actual discharge is equal to CD A1 A2 square root of 2GH divided by square root of A1 square minus A2 square. Because I cannot see the formula in the first page, so I have done once again. Now here we don't know A1 A2. H you have calculated. So A1 is equal to pi by 4 D1 square. This is a formula, very important formula, which is pi by 4 D1 square. What is the value of A1? He has given 30 centimeter. We take 0.30 meter square. So A1 is equal to approximately, I will get 0.706 meter square. So this is the value of A1. Similarly, I will calculate the A2 using the same formula pi by 4 D2 square. So A2 is equal to pi by 4 D2 square, pi by 4. What is the value of D2? D2 is 10 centimeter, that is 0.10 whole square. So A2 is equal to, I will get 0.078. 0.0078. 0.0078 meter square. These are the two values of area at inlet and throat that I will substitute here. CD value, it is there on the page, 0.98 into A1 is 0.706, A2 is 0.0078, square root of 2, G value is 9.81, H value, which H you will consider, there are two, extra additional heat loss and as well as one more H. This H is pressure difference head or difference in pressure head. That only one H value you have to calculate, that is 19.03. So don't take it as a combination of both or extra what he has given 4% of this. No, it is wrong. Okay. So here H value is 19.03. So divided by square root of 0.706 whole square minus 0.0078 whole square. So once you substitute all the values in the calculator, and 0.149, 0.14, there will be slight change, depends upon number of digits you have taken in the putting in calculator.